Now you'll hear a lot of stuff about what a lot of calculus teachers they'll introduce this concept, this formula you see here called the quotient rule, and here you go, the quotient rule, and it's here on the screen for you. Although we're not going to use this formula, mostly because I think it's not necessary. You know, I want you to memorize the least number of formulas just to make math easier, and this is definitely a formula that's not necessary. The quotient rule is supposed to be used when you have a quotient. So when you have u divided by v, right, then you can use the quotient rule to differentiate this whole quotient. And this is the formula, as I was pointing out earlier. However, why do you need a new rule to differentiate this quotient when you can just write this like this as a product and then differentiate this as a product, because we have a product rule. So why do we have to learn a quotient rule for quotients if every quotient could be written as a product? It's just a waste of time having to learn another formula, and it's a waste of space in your brain. So we're not going to learn a quotient rule because I think it's stupid. But instead, we're going to do practice problems with the product rule for quotients. First practice problem, f of x equals x plus 6 over x plus 3. So the first thing we do would be to, before we can actually take the derivative, we must write this as our product. Now this, you'll see, we actually can't differentiate this. Not with techniques. We haven't learned the techniques necessary to differentiate this yet, actually. So this is how you would write it as a product. And then from this point on, what would you do? Well, you would refer to the I don't have the product rule written here. Okay, this is the product rule, right? This is, it's not equal sign, but u prime v plus u v prime. That's the product rule. And so you have to take the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. The problem is we can't find the derivative of the second. We don't know how to find the derivative of the second because we don't know how to find x plus 3 to the negative 1. We don't know how to find that as a derivative. Because remember, these are equivalent. That is equivalent to that. So, but we can't find the derivative of this. We have to learn the chain rule first in order to do that. And actually, the chain rule really doesn't apply in this instance to the underlying portion, but it's kind of wrong to assume you can find the derivative of the underlying portion without at least knowing the chain rule. Anyway, but my point wasn't to actually do the product rule. It was to, I mean, that helps to do the product rule, but just to, it helps also just to show you how to get to the point where you would be applying the product rule, and then, you know, if this was another problem, a different problem, that you did actually know how to do the product rule without having to know the chain rule, then you could actually completely do this problem. So let's do another problem that you can actually do. Same color, good. Why don't you take a crack at this? Just see if you can do this question. Pause the video, come back. Okay, let's see how good you were, how close you could get. So we're going to write this as a product first, so we can use the product rule. 5x plus 2 times 1 over 2x squared. Okay? Now, it would help to write this with negative exponents, right? 5x plus 2 times 2x squared to the negative 1. Alright? Now what's 2x squared to the negative 1? You can actually, you can solve that. If you just solve that, what do you do with negative x, or not negative exponents necessarily, but what can you do? You can multiply exponents across, do cool stuff like that. Yeah, so in an instance like this, that would mean having 5x plus 2, the 2x squared to the negative 1, you have to raise both the 2 and the x squared to the negative 1 power. So you have 2 to the negative 1, or 1 over 2, times x squared to the negative 1, or x to the negative second, because you multiply the exponents. Okay, well, okay, now I think we can actually differentiate 5x plus 2 times a half x negative 2. Whoops. 5x plus 2, half x negative 2. 5x plus 2, a half x negative 2. There you go. Now we can actually differentiate. And if I were differentiating this, I would use the product rule, of course, and u prime v plus u v prime. So, derivative of first factor, that factor I mean, is 5, times second factor, a half x to the negative 2, plus the second factor, 5x plus 2, times the derivative of the second factor, which is negative 2 multiplied by a half gets you your coefficient, so negative 1, right? Negative 1x, and then you subtract the exponent by 1 to get negative 3, right? Okay, negative x to the negative 3, and that's your derivative. And I don't know if your teacher wants you to distribute like here, or I don't even know what your professor would want in that instance. If he wants you to distribute, well, I think you know how to distribute this. If you've gotten this far, you probably know how to distribute. So I'll leave it at this, and we can call this our answer. So this is what you would present to to your teacher. This is what you would box on your test or your homework or whatever, if he or she is okay with you multiplying these things out. Which I don't know, it's more of a preference thing, whatever the teacher wants. So I wanted in this video to point out that when it comes to finding the derivative of quotients, we are not going to use the quotient rule. U prime v minus uv prime over v squared. Yeah, you don't need to memorize another formula. Trust me, there's going to be enough stuff for you to memorize in calculus. So I just want to lessen the number of formulas you have to memorize, if possible. And this is one easy place where I think I can lessen the number of formulas you need to memorize, because the quotient rule is not something that is, you don't need to really know it. And so I am suggesting using the product rule when you have a quotient by writing the quotient as a product. Hopefully it will be easier for you as far as remembering, having to remember all the different rules and stuff, and just facilitating the differentiation process. Okay, there you go.